Hello and welcome back to my channel Learn with Nikhil. So in our previous lectures, we have seen and studied the DH parameters. Now using the DH parameters, we will find the kinematics of the robot. So kinematics is divided into forward and inverse kinematics. So first we will study kinematics. Now the main difference between the kinematics and the dynamics is that kinematics is the study of the motion of the links without considering the forces. So kinematics is just the study of the motion of the links, and when the forces are considered, that is nothing but the dynamics. Now to understand kinematics, so in forward kinematics we have the values of theta 1 and theta 2. So we have the angles. So when we know the angles, we find out the coordinates. So this is the robot, and when we know the values of the angles, so theta 1 and theta 2, we know the angles, and using these angles we find the coordinates. So this is the position of the end effector. So this is the position of the robot. We find this using this. That is the forward kinematics. And inverse kinematics is nothing but when we know the position of the end effector. So I know the position of this end effector and we find out the angles. So if I want to reach this particular position, we have many options to reach this particular point. Now in this type of robot where the degree of freedom is 2, we can reach like this also, or you can reach like this also. So in inverse kinematics we have 2 or more than 2 solutions. So forward kinematics, we know the value of theta 1 and theta 2. So we know the angles and we have to find the coordinate of the end effector. That is forward kinematics. And in inverse kinematics, we know the position of the end effector and we find out the angles. So we have many values or many solutions in inverse kinematics. And finally going back to the angles. So this is the kinematics where we will study forward and inverse kinematics. So this is the example we have studied earlier in our previous lectures. We have found the DH parameters. If you want to study this again, you can go to the previous lectures and you can see how I have found the DH parameter for this particular robot. In short, if you see, this robot is in 2-dimensional. The z-axis is coming outwards. The z-axis of these 3 joints, these 2 are the rotary joint and this is the end effector. The z-axis is parallel for all 3. So for that purpose, the twist angle is 0. Link length L1 and L2 is nothing but this. This is the link L1, this is the link L2, and these are the theta angles. So these are the DH parameters. Now first I'll explain and let you know how to find out the forward kinematics of this robot using the DH parameters. I'll show you how to calculate it manually and also I'll show it using the Robo Analyzer software. So let's begin. First we'll see how to calculate the forward kinematics manually. So this is the particular robot. Now to understand the forward kinematics and to find the forward kinematics of this particular robot, that means you have to find out the position of this end effector. So this is the end effector, so you have to find the position of this end effector with respect to its base. So to find the position of this with respect to the base, you have to first find out the position of this with respect to this joint and then this with respect to this joint. I'll repeat again. If you want to find the position of this end effector, that is Qx and Qy, with respect to this base, we have to find the position of this with respect to its previous joint, this with respect to the previous joint. Then both you have to multiply and then we'll get the coordinate of this end effector. So we have to find out Q capital X, Q capital Y, and the known values here are theta 2, theta 1, link of the length that is L1 and link of the length that is L2. So to find the forward kinematics, let's begin. So as I have discussed right now, that you have to find the end coordinate, the position of the end coordinate, that is nothing but transformation of 2. This is joint 2 or the link 2. So 2 is nothing but the position of this. So this is the second, this is 1. So this is joint number 1, this is joint number 2, this is joint number 0. So this is joint number 0, this is joint number 1, this is joint number 2, this is link 1, this is link 2. So transformation of joint 2, that is the end effector with respect to the base. So this is the base and this is 2. That is joint 2, which is end effector, which is equal to the transformation of 1 with respect to base. So transformation of joint 1 with respect to base multiply by transformation of 2 with respect to the previous, that is 1. So transformation of this with respect to this, that is this, and transformation of this with respect to this, that is this. So multiplying both this will get me the transformation of 2, that is this, end effector with respect to the base, which we have to find out, and this is nothing but forward kinematics. So we will find these two separately and then we'll multiply it. So first, finding out transformation of joint 1 with respect to base. So transformation of joint 1 with respect to the previous or the base, that is nothing but, now in this robot you can see the z axis is parallel to each other. So z axis is parallel, so twist angle is 0, and here you can see you have theta values and you have the length of the link. So this link is moving along z axis. So this is moving along z axis. Z axis is common and it is moving along z axis. So the transformation of 1 with respect to base is nothing but rotation about z axis at an angle of theta 1. So rotation of about z axis at an angle of theta 1 multiplied by transformation along x axis. So this is transformation along x axis at a length of L1. So I'll repeat again, transformation of 1 with respect to base is nothing but rotation about z axis at an angle of theta 1. So first you have to rotate this at an angle of theta 1. So this angle is theta 1 and it is rotated along z axis. So first it was straight, first we rotated along z axis at an angle of theta 1, then we transform this, transfer this coordinate along this link and we transfer it along x axis. As you know, the x axis is always in parallel with the link. So we transfer along x axis and we rotated along z axis at an angle of theta 1. So this is this rotation of z at an angle of theta 1 and then transformation of link L1, that is the length L1, along x axis. So rotation and transformation. So for finding this, as we have studied, so this is the 4x4 transformation matrix. This 3x3 is the rotation along z axis. This is cos theta 1, this is minus sin theta 1, this is sin theta 1, this is cos theta 1, and this is 3x3 matrix, and this is the transformation or the position matrix. Now this is transfer along x axis. So this is L1 cos 1, this is L1 sin 1. This we have studied in our previous lecture and we have found out this. So this is rotation, this is the rotation part and this is the transformation part. and this is the transformation of 1 with respect to base. Likewise, we have to find out the transformation of second with respect to 1, and that will be nothing but z. This is z, rotation of z at an angle of theta 2. So rotation is again, this is z here, so rotation along z at an angle of theta 2, and then transformation along x-axis with the length of L2, and that will be again a 4x4 matrix, where this is the rotation along z at an angle of theta 2, that is cos theta 2 minus sin theta 2, sin theta 2 cos theta 2. So this is the 3x3 matrix of rotation of z at an angle of theta 2, and this is the transformation matrix, which is L2 cos theta 2, L2 sin theta 2. So this is the 4x4 matrix. So we have got these two 4x4 matrices for this, and multiplying both this, we get this total matrix, the 4x4 matrix, and this is nothing but the transformation of end effector, that is 2 is nothing but this end effector with respect to the base. So we have found out this whole matrix, where this is cos theta 1 plus theta 2, so cos into bracket theta 1 plus theta 2 minus sin into bracket theta 1 plus theta 2, this is sin into bracket theta 1 plus theta 2, cos into bracket theta 1 plus theta 2, and this is L1 cos theta 1 plus L2 cos theta 1 into cos into bracket theta 1 plus theta 2, likewise this also. So this is nothing but cos theta 1 plus theta 2, and this will be sin into bracket theta 1 plus theta 2, and this total is nothing but qx, q capital X and q capital Y. So this is the positions, or this is the coordinate of the end effector. So these are the coordinate of the end effector with respect to the base. So in forward kinematics, we know the values of theta 1, theta 2, L1 and L2, and we have to find the position of the end effector. So how length or how the robot will move, we have to find the coordinate of each and every position. So this is nothing but forward kinematics. Now I'll explain this using the Robo Analyzer software also, how to find these values. Now this is the home page of the Robo Analyzer software. Now to find the forward kinematics of this robot, we have to find this final matrix. This is the 4x4 matrix. So to find this, I'll explain this step by step using this Robo Analyzer software also. So as you know, this robot, now it is in 3-dimensional. This is the z-axis. This all are parallel. So here also, this is one rotary joint, this is the second rotary joint, and this is the end effector. So this is one rotary joint, second rotary joint, this is the end effector. The z-axis are parallel to each other. Here also the z-axis is coming outward and coming outward. So this all three are parallel to each other. So the twist angle is 0. And this will move in 2-dimensional. It will always move in xy plane only. Now, so according to this, so the link length here, it is 0.2. So this is 0.2, this is 0.2. This L1 is 0.2, L2 is 0.2, and the angle. Now here the angle is given 0, initial value is 0, final value is 180 degree. Here also the initial value is 0 and the final value is 90 degree. So the difference wise, this is total 180 degree, this is total 90 degree. If I make this both 90, so the initial value is 0, final value is 90. So the total is 90 degree. Now to find or to visualize the matrix, now here we have find out the transformation of 1 with respect to base. So transformation of 1 with respect to base, we have found out that rotation is across z at an angle of theta 1 and transformation of x along length L1. You can see here also, this is the revolute joint or the rotary joint. the variable angle is theta, link length is 0.2. So here you can see the joint offset, joint angle and the link length. So this is the transformation from this point to this point. This we have already studied, the DH parameters. Now to find this matrix, you can go to the link configuration. So this is the link configuration, this is T, that is the transformation matrix. So here you can drop down and select link 1 and link 2. So first I have to find out the transformation of link 1 with respect to the base. So this is the base and this is the link 1. So transformation of link 1 with respect to the previous link frame or the base frame. So I have selected here the base frame. So transformation of link 1 with respect to the base frame. Now if I click on update, I'll get a matrix. So this is the transformation matrix of link 1 with respect to the base frame. So this is the link 1 with respect to the base frame. This is the transformation matrix. You can visualize this. So this is 1 0 0, this is 0 1 0 0 0 1. Now you can put these values into this matrix. So as now here this is the initial value is 0, this is 0. So now it is cos 0, sin 0, sin 0, cos 0. So the values put here is 0. If I click on forward kinematics and go to its end position, now if I change this and move to its end position, now at this particular end position, link transformation of link 1 with respect to the base frame, now its final value is considered, that is 90 90. If I click on update, now this is cos 90 minus sin 90, this is sin 90 and cos 90. The value of cos 90 is 0, sin 90 is 1, so it is minus 1, sin 91, here it will be 1, and cos 90 is 0, so here it is 0. And this is nothing but the transformation of x with respect to L1. So transformation with respect to x, the length link is L1, and as you know the length link is 0.2. So here we have got the value 0.2. So this is the rotation matrix 3 by 3 and this is the transformation or the position matrix. So 0.2, this value has arrived here. If I go back to this initial position, so initial position, initial value is 0. So transformation of link 1 with respect to the base frame, if I update it, now as you can see the initial value it is 0. So now here cos 0 is 1, so the value is 1. Then you have sin 0 is 0, so the value is 0. Then again sin 0 0 and cos 0 is 1, so here the value is 1. And the link 1 with respect to the base frame, here the value is 0.2. So again this is the qx value which is 0.2. Now I am clicking on the forward kinematics. You have to find the position of this with respect to this. So now this is nothing but the position of the link 1 with respect to the base frame when its initial value is 0. Likewise, if I just click on this, now while it's moving, I click on update. So it's the middle value which I have got this. So this might be some angle might be. So that is the value according to that. So we have got this random theta value and these are its random value, and also the length of the link and the random value. The length of the link is nothing but L1 cos theta 1, L1 sin theta 1. So we have put these values and we have got these values. So this is how we have found the transformation matrix, this 4x4 matrix, using this Robo Analyzer software. So this is just for the base T1 with respect to base. Same for T2 with respect to the previous frame. So now if I click here on the link 2, so transformation of link 2 with respect to the base frame. Now this is the total, but we want the transformation of link 2 with the previous frame. So now the transformation of this is the link to with respect to the previous frame. So this is the previous frame. So now here the transformation of link to this with respect to the previous. Now here you don't have any coordinate. You can visualize this DH parameter also, and you can see the link configuration. So link to with respect to the previous frame. So we have got these values. As you can see, the rotation of Z, theta 2, transformation of X, and length is L2. So again we have these two values. Initial value is 0, final value is 90 degree. So I have updated. So this is theta is 0. And if I click on the forward kinematics and go to the end position, now the theta value is 90 degree. I have updated. So according to that, I have got the theta values. So this is this value. So sine 90 is 1. Now we can convert this link to with respect to the base frame also. So this is the final answer when we multiply both this. So this is the matrix 4x4 matrix, and this is nothing but the link to, that is the end effector with respect to the base frame. So link to, this is the end effector with respect to the base frame, update. So this is the whole 4x4 matrix. Now here the theta value considered is 0 because this is the initial position. And if I go to the final position, if I update, now the theta value is 90 degree. You can change the theta value. I'll change this to 45. I'll change this to 45. You can go to the end position. So now the theta value is 45. So according to the 45, these values have been changed. So this is the link configuration. You can also check the EE configuration. This is the final matrix. This will be same as this because this is transformation of link to, that is the end effector with respect to the base frame. So this is, and this will be same because here you get the combined thing. This is the same transformation of end effector with respect to the base frame. So this is the 4x4 matrix, which is this. So we have seen manually also how to calculate it, and we have seen using Robo Analyzer software also. Thank you for watching. Do subscribe. See you in the next lecture.